Welcome to Spring LIB.
In this question, we have a sinusoidal wave that is traveling on a string in the negative x direction, and it has an amplitude of 1 centimeter. It has a couple of parameters. So let's just try to write down the expression for it. It has an amplitude of 1.00 centimeter. So let's say everything is in terms of centimeter. That is, the amplitude is 1. It's sinusoidal. And then we have kx minus omega t, except that its traveling is negative x direction, so this is actually plus omega t. The wavelength is 3 centimeter. So lambda equals 3 centimeter. Amplitude equals 1 centimeter. Lambda equals 3 centimeters, so k equals 2 pi over lambda. And this gives us what k is. So last one, it says the frequency f equals 245 hertz. And we know omega equals 2 pi f. And that gives us what omega is. So at t equals 0, the particle string at x equals 0 is displaced by a distance 0.8 centimeters. So what that is saying is that t equals 0, x equals 0 equals 0.8 centimeter. So, and it's moving upward. What that says, that is to say, this actually, there is a phase difference in the sign. Or another way to think about this is that it has, it may also have an offset. So it's possible that you also have something like this plus a constant. But I will assume that it is a phase difference. So the first thing we need to do is we need to draw a diagram for this wave. So the amplitude is 1, but this point is 0.8. This is moving upward. So since the wave is traveling to the left, this has to look something like this. And the wavelength is 3 centimeter. So this is not quite the right scale, but this distance should be roughly 3 centimeter. And I think that is roughly it. Yeah, I think that is it. We need to make sure this is 3 centimeter. We need to make sure this is 0.8 centimeter. So, okay, so the second part, of course, is to figure out the expression for it. We already list everything, and we can now start to calculate it. 2 pi over 3 centimeter equals 2.09 centimeter hertz. This is 2 pi times 245 hertz is 1540 per second. And the last one is this equals 0.8 centimeter. And it also equals, when x is 0, this is sine phi. So phi is arc sine of 0.80 equals 0.93. So finally we have the expression d equals sine. There's 1 centimeter. I know it's 1, but I'll just put it here just because it carries a unit with it. Well, let me rewrite this equation with all the units in it, because that is better practice. meter times sine of k is 2.09 centimeters k times x plus omega radian times t finally plus 0.93. And the unit x is in centimeter, t is in second. This is the expression that we're trying to find.